Welcome back to our channel. In today's video we talk about comets, these beautiful celestial bodies, understanding how they are made and why they are so fascinating. Before starting, I invite you as always to subscribe to the channel, activate the bell and leave a like. Comets are small celestial bodies present in the solar system. We often hear these objects referred to as comets, but as we will see shortly, they are not stars at all. The word comet comes from Greek and means with hair. In fact, these celestial bodies, as we will see shortly, are surrounded by a luminous halo made of gas and dust which is called coma. As already mentioned, comets are part of the so-called minor bodies of the solar system. But let's understand better how they are made. Comets are made of a nucleus, a coma and a tail. We will see shortly that there are actually two cues, but let's proceed step by step. Let's talk about the core first. The nucleus of a comet is solid and has a size ranging from about a few hundred meters to a few tens of kilometers. Being small, comet nuclei do not have such a strong gravity that they become spherical. So we can find nuclei of various shapes. They are made mostly of ice, rock and dust. They also have traces of frozen ammonia and are also rich in organic compounds, i.e. carbon-based, which gives the nuclei a typically very dark color. When they are far enough from the Sun, only the nucleus is visible in comets. Therefore, when they are sufficiently distant, comets are completely the same as asteroids, with the only difference that they are rich in ice and other frozen volatile elements. They are therefore very difficult to observe because they appear as small celestial bodies in the distance and are typically very dark and therefore not very bright. An example is Churyumov-Gerasimenko. This comet was visited by the Rosetta probe in August 2014. The probe, while in orbit, studied the comet closely and released a lander called Philae which, for the first time, landed on the nucleus of a comet. Philae had the opportunity to study the comet up close as had never been done before. Now let's talk about the other two typical elements of a comet, the coma and the tail. When the nucleus of a comet approaches the Sun, very interesting things happen. At a distance of about 34 astronomical units from the Sun, therefore more or less between the same distance traveled by Mars or Jupiter from the Sun, the light from the Sun heats the nucleus of a comet so much that the icy elements of which it is composed begin to sublimate, that is, they evaporate. Since most of the ice is found under the so-called crust, a layer of rock a few meters thick, or in the fractures of this crust, when it begins to sublimate the ice it takes with it a lot of the material present on the surface of the core, so it mainly brings behind rock debris and dust. This set of evaporated ice, therefore of gas and debris shot away from the surface of the nucleus, forms a halo or rather a sort of atmosphere that surrounds the nucleus. This atmosphere is called coma. The grains of dust that make up the coma reflect the light of the Sun, making the coma luminous. Not only that, although the size of the nucleus of a comet is a few kilometers, the coma can even extend for a few thousand kilometers, if not even a few million. In fact, Comet 17P, Pucatel, a comet with an orbital period of about 7 years, in 2007 had a coma with a diameter of about 1 million kilometers, or about 70% of the diameter of the Sun. Comets typically have very eccentric orbits. That is, they pass very close to the Sun and then go very far away. This implies that as a comet gets closer and closer to the Sun, the outgassing phenomenon becomes increasingly important. So, in fact, the comet loses more and more material. In reality, when the coma is formed, another characteristic element of comets is also formed, the tail. As I said before, there are actually two cues. Let's see them in detail. The first tail, called a dust tail, forms when sunlight interacts with dust in the coma. The finest grains of dust are literally pushed away by the light of the Sun. In fact, the radiation pressure is said to push the grains of dust away, forming a tail. This dust tail is very bright because it is made of fine dust grains that reflect the light of the Sun. The dust tail is typically curved, because the movement of the dust grains of which it is composed is the sum of two contributions. The first it is the direction with which the comet's nucleus ejected these grains. The second is the direction in which the sunlight pushes them. For the brightest comets, this tail is even visible to the naked eye from Earth. The second tail, called the ion tail or gas tail, is formed differently. When sunlight encounters the gas molecules that make up the coma, It breaks them apart through a process called photolysis or strips electrons from them through a process called photoionization. At that point, the gas that makes up the coma becomes a plasma, made of particles that have an electric charge, in particular ions, or atoms as I said before that have lost some electrons, and free electrons. Well, the ion tail is formed by the interaction of this very plasma with the solar wind. The solar wind is the set of charged particles fired by the sun into the space around it. These particles carry with them part of the magnetic field generated by the sun. When the solar wind interacts with the plasma in the coma, it pushes it away, forming the ion tail. This tail, unlike the dust tail, always points in the opposite direction to the sun. This is because the plasma of the tail tends to follow the lines of force of the magnetic field generated by the sun. When the particles of the plasma of the tail recombine to reform gas molecules release energy in the form of light, typically blue. Unfortunately, however, the light emitted by the ion tail is very weak, so it is difficult to see with the naked eye even for the brightest comets. Now let's recap the situation. The tail of dust, very bright, is made up of small grains of dust from the coma that reflect the light of the sun and are pushed away by the light itself. The dim ion tail is made of plasma from the coma that is pushed away by the solar wind. This tail follows the magnetic field lines of the sun and therefore always points away from the sun. Larger, more massive debris tends to remain along the comet's path. This is because they are too heavy for sunlight to push them away. This debris, left along the comet's orbit, for a perspective effect, can appear to us like an ancient dart, i.e. a fake tail that appears in the opposite direction to the other two. The famous tails of comets can even extend for a few 100 million kilometers. In fact, the comet with the longest tail ever recorded is Comet Hale-Bopp. This comet returns close to the Sun every 70,000 years. Passing close to the Sun in 1996, it had a tail 570 million kilometers long, almost 4 times the distance between the Earth and the Sun. Sometimes the Sun's magnetic field can close right behind a comet through a process called magnetic reconnection. When this happens, the comet can temporarily lose its ion tail. After passing close to the Sun, comets dive back into the depths of the solar system, losing more and more material. This means that every time a comet returns to visit the internal areas of the solar system, it becomes smaller and dimmer. Eventually, the comet burns out completely and becomes an asteroid-like object. Comets are fascinating not only for their beauty, but also because they allow us to learn more about the history of our solar system. In fact, comets are thought to be largely composed of remnants from the formation of the solar system itself. By studying comets, we can therefore learn more about how our solar system formed and how it has evolved over time. Furthermore, comets could also be bearers of life. In fact, comets contain traces of organic compounds, the basic building blocks of life. This means that comets may have played an important role in the birth of life on Earth. Thanks for your time and see you in the next video.